In traditional product planning, requirements are set at the beginning of the project, while with Scrum, an Agile framework, requirements develop concurrently during the project. Which is best? Does a mix of the planned and the Agile requirements development work well? If so, how do you determine how much to plan and how much to develop during design? Hello, I'm David Ullman. I've been designing products and teaching others how to design products for over 40 years. I've recently begun using the Scrum framework to help manage the hardware design process. Scrum is an Agile framework widely used in software design for improving communication and helping the team cope with uncertainty so they can make sound design decisions. By hardware, I mean everything but software. However, what I will tell you will interface well with your software colleagues. Whether using traditional planned design methods, the Scrum framework, or a hybrid of the two, understanding the product's requirements is very important in terms of design time, cost, and product quality. This video is part one of a four-part series about hardware requirements. What do I mean by a requirement? Here, requirement is synonymous with specification or customer need, in the broadest sense of the term customer. A traditional and dated definition of a requirement is something that governs what, how well, and under what conditions a product will achieve a given purpose. A more modern definition is simpler and focuses on the customer and the design team with a requirement is a shared understanding of what is needed. This shared understanding is built on conversations with the right people about the right topics at the right times. Important here is having conversations that answer the following four questions. What is being designed? For whom? What does it need to do? And how will you prove the need is met? Answering these four questions will facilitate the key conversations needed to develop good requirements. A question is, why bother to spend time developing requirements at all? First, these conversations build a shared understanding between the team and the customers. Second, experiments and industrial benchmarks have both shown that the quality of the final product is directly proportional to the time spent understanding the needs. Based on these benchmarks, about 7% of the total design effort should be devoted to requirements development. Finally, requirements development, if done well, decreases the overall design time as it reduces rework. This brings us to a design dilemma. Without requirements, new features creep into the product and the project may be over budget and late with unnecessary features. However, too much effort on requirements up front is a waste of time as changes occur with learning and design is learning. The goal is a balance, the topic of our fourth video in the series titled Deciding How to Develop Hardware Requirements. The first key conversation answers the question, what is being designed? This is important as there's nothing more wasteful than people working together on different things. Whether designing a system, assembly, module, or a part, the first question is, where does the object fit in its environment? An object is defined by its interfaces with the people and systems around it, and these drive the requirements. Hardware objects must have a form that physically mates with other objects. The requirements on the interfaces between them must be negotiated in conversation with those designing on the other side of the interface. Even more important, objects function through the interfaces with other objects and with people. By function, I mean the flow of information, energy, control, or materials in and out of the object. The better the flows through the interfaces can be identified and refined, the higher the likelihood of design success. The second conversation aims to identify the customer, or who cares about what's being designed. During software design, the primary customer is the user. For hardware, everybody or every adjacent system that interacts through the interfaces is a customer. This is the manufacturers, assemblers, distributors, installers, users, cleaners, disposers, and so on. This includes all the adjacent objects that work through the interfaces. The third conversation that needs to happen answers the question, what does it need to do? This conversation forms the core of the requirements. Both traditional planning methods and the Scrum framework provide tools to support this activity, as will be addressed in the second and third videos in this series. The goal here is an itemized list of requirements. During the design of an aisle chair, for example, a wheelchair to move passengers through an airplane aisle, both the QFD and Upfront Requirement Development Tool and customer story methods used in Scrum and Agile framework have been employed. Here, the planning requirements are shown on the left as developed using QFD. They have been refined into a parent-child format, with one child being the boxed requirement, easy positioning of the seat height. As can be seen, the story format on the right develops a similar result. And the final conversation answers the question, how will you prove the need is met? It is critically important that every requirement has a measure and a target. One way of forcing these is to think in terms of test-driven development, TDD. With TDD, the tests that prove that the requirement is met are defined as the requirement is developed. Here, one height positioning system measure, target, and test is shown. So in summary, developing requirements is having conversations about what is being designed, for whom, what does it need to do, and how will you prove the need is met. The focus of video 2 in this series is the use of the Quality Function Deployment QFD method to answer the 4 key questions, a part of project planning. This material is based on Chapter 6 of the text, The Mechanical Design Process. Video 3 shows how stories in the Scrum framework facilitate the conversations. Finally, the 4th video, we will explore how to balance how much should be done up front with how much should be agile. Thank you for watching. Be sure to subscribe so you don't miss the next video on hardware design best practices.